Alright folks, let's play a little game. I'm going to show you a few images and you have to guess what do they all have in common. Did you guess it? Yes, they're all beautiful and no, they're not any
secret society symbol either.
The answer is a bit more magical. Something that has been captivating minds for centuries. It's a mathematical ratio that appears in nature, art, architecture, and almost everything. This number, believe it or not, is the secret ingredient used by nature and artists alike to craft beauty and harmony. It is called the golden ratio and it is represented by the Greek symbol phi. So let's understand the magic of the golden ratio and find out why it's everywhere we look. My name is Siddharth and you're watching the world of science.
After all, the universe is a strange place.
When you study nature, you see the golden Fibonacci numbers like 3, 5, 8, 13, all of that again and again.
Is there really such a sacred formula that rules over everything?
The golden ratio.
There is a deep historical connection between mathematics and art. I mean, think about it. Music, dance, painting, architecture, sculpture, graphic design, they all have traces of math in them. From ancient times, philosophers viewed the universe as a grand map to contemplate the divine. Everything in the cosmos was thought to be a manifestation of perfection. The material world was supposed to be a flawless geometrical construct, and every object was supposed to contain a universal feature that defined the beauty of the world. Ancient Indians, for example, saw temple architecture as a way to link humans to the divine, representing cosmic beings in perfect geometrical forms. A perfect geometry in the physical world, ideal alignment of dimensions in temples, perfect shapes of celestial bodies, repetition of numbers in music, solar and lunar days, and so much more. Mathematics and art were quite interrelated in almost everything for our ancestors. And it was not just an adventure to search for mathematical relations in the beauty of natural objects. It was also a sort of duty to use those relations to create perfect man-made architecture. Fast forward to 4th century BC, a Greek sculptor named Polykeitos wrote a treatise on carving the perfect sculptures for gods and warriors based on mathematical proportions. He recommended the ratio 1:√2 for the perfect male body. And even before Polykeitos, great minds like Pythagoras and Euclid were obsessed with ratios. Pythagoras, for instance, discovered that while playing a musical instrument, a string exactly half the length of another string would play the same note, but exactly an octave higher. This, along with several other ratios that he found, led to the development of Pythagorean tuning in music, in which every interval is tuned based on the ratio 3:2. And they still use today. The mysteries of ratios in nature have fascinated minds from Da Vinci to Kepler, and even today they remain a hot topic of conversation. And then there's the most famous ratio of them all, the golden ratio, represented by the Greek letter phi. Ancient Greek mathematicians first observed the golden ratio in geometry. They noticed that in the geometry of regular pentagons and pentagrams, there is a frequent appearance of a section known as golden section. As Euclid defined in his famous treatise Elements, a straight line is said to have been cut in extreme and mean ratio when, as the whole line is to the greater segment, so is the greater to the lesser. This is the earliest known definition of the golden section or the golden ratio. To put it in simpler words, take a straight line and divide it into two segments, the longer one A and the shorter one B. Now, these two segments would be in the golden ratio if the ratio of the entire section A plus B to the longer segment A is the same as the ratio of the longer segment A to the shorter segment B. Mathematically, this is written as A divided by B is equal to A plus B divided by A is equal to phi, the golden ratio. When we solve this equation for a possible solution of phi, we get a quadratic equation which is phi square minus phi minus 1 is equal to 0. Now, you might ask, how did we get there? Let me break this down for you. Let's split the right side into two fractions. A by b is equal to a by a plus b by a. Since a by b is defined as phi and a by a simplifies to 1, the equation now becomes phi is equal to 1 plus b by a. Here, we know that a by b is defined as phi, which allows us to substitute b by a as 1 by phi and get the equation in its simplest form as phi is equal to 1 plus 1 by phi. After multiplying both sides by phi and rearranging the equation, we get the quadratic equation phi square minus phi minus 1 is equal to 0. There you have it. Now using the quadratic formula, phi is equal to minus b plus minus under root b square minus 4ac whole divided by 2a, and substituting the value of a, b and c as 1, we get 1 plus root 5 whole divided by 2, which is equal to 1.61803398874989484820. This isn't ending, man. The digits just keep on going with no pattern. In fact, golden ratio is known as an irrational number. But we can consider only 1.618. This tiny number, 1.618, is the famous and mysterious golden ratio. Mysterious because it keeps appearing in almost every field, like some fine-tuned property of nature. In fact, our brains are seemingly hardwired to prefer objects and images that use the golden ratio. It's almost like a subconscious attraction, and even tiny tweaks that make an image truer to the golden ratio have a huge impact on our brains. Now look at this rectangle. It has been made using the golden ratio. Looks like a typical frame for a painting, doesn't it? Many artists and architects believe that golden ratio makes the most pleasing and beautiful shape. In the 13th century, Italian mathematician Fibonacci introduced his famous sequence, the Fibonacci series, where every number is the sum of its two preceding ones. Now, if you observe more closely as the numbers get larger, the ratio between two successive numbers approximates the golden ratio. Fibonacci had no idea about this connection, but later mathematicians like Simon Jacob and Johannes Kepler discovered it. Another Italian mathematician, Luca Pacioli, wrote a book in the early 16th century and called this ratio the divine proportion. He showed that it appears in Platonic solids such as tetrahedron, octahedron, and dodecahedron. Pacioli also advocated that the appearance of the golden ratio yields harmonious and pleasing proportions. His work inspired none other than Leonardo da Vinci, who applied the golden ratio in his artworks. If you don't believe me, have a look at his most famous painting, the Mona Lisa. Notice how he has applied the golden ratio in the head region, the torso, and almost the entire painting for that matter. Or let's talk about the Last Supper, in which the architectural features and the positions of the disciples of Jesus around him show the placement in terms of exact proportion. The same can be observed in the Vitruvian Man. This fascination didn't stop there. Mathematicians like Bernoulli, Euler, and many others in the 20th century found connections between the golden ratio and numerous mathematical objects. But the real magic happened when researchers found golden ratio in biology and nature. For instance, the spiral found in the sunflower seeds and pine cones follow the golden ratio. In both cases, the seeds grow along two spirals that move and cross in different directions. In the case of pine cones, there are 8 seeds in one direction and 13 in the other. In case of sunflower seeds, the numbers are a little larger, 21 and 34. Now, if you divide 34 by 21, the number that you get is very close to 1.618. This spiral, known as the golden spiral, can be found in hurricanes, seashells, and even human skulls. A study from Johns Hopkins University in 2019, published in the Journal of Craniofacial Surgery, compared 100 skulls and found that golden ratio is embedded within them. The dimensions and arrangements of components within the skull follow this ratio. Research by Adrian Bejan of Duke University suggests that the human eyes interpret images with golden ratio faster than the ones without it. Our brains are somehow wired to see the golden ratio as harmonious and beautiful. That's why we're amazed by structures such as the pyramids, the Parthenon, the Notre Dame Cathedral, and the huge Buddhist stupas. There is golden ratio everywhere, from flower petals to tree branches to spiral galaxies. Even the DNA molecule has dimensions that align with the Fibonacci sequence. Each complete cycle of its double helix structure measures 34 angstroms in length and 21 angstroms in width. Sounds familiar, doesn't it? Now this is just amazing. The golden ratio is a concept that bridges natural beauty and scientific practicality. And it's not just a part of architecture or some masterpiece, it's hardwired into our perception. The golden ratio is a part of nature, a part of us, and it is what makes the world around us so beautiful and aesthetically pleasing. So what do you think about the golden ratio? Have you noticed it around you? Let us know in the comments. If you like this video, please give it a thumbs up and share it with your friends. Make sure you subscribe to the World of Science. Until next time, stay scientific.